Ever wondered how batteries power your devices? It's a question that tickles the curiosity of many, and today, the veil lifts. Welcome to the intriguing world of voltaic cells. Imagine two separate containers filled with a liquid called electrolyte. Each container houses a metal rod, known as an electrode. One electrode is of zinc and the other of copper. These two electrodes, dipped in their respective electrolytes, form the heart of a voltaic cell. The zinc electrode undergoes a fascinating process called oxidation. In this process, the zinc atoms lose 2 electrons each, transforming into positively charged zinc ions. These zinc ions then plunge into the electrolyte solution, leaving the 2 lonely electrons behind on the zinc electrode. On the other side of our voltaic cell, in the other container, the copper electrode is waiting. It's waiting for the electrons that the zinc electrode just lost. These free electrons travel from the zinc electrode through a wire and onto the copper electrode. This movement of electrons from one electrode to another is what we call an electric current. But wait, the story isn't over yet. The copper electrode is submerged in a copper sulfate solution. This solution is filled with copper ions. When the free electrons arrive at the copper electrode, they encounter these copper ions. The free electrons combine with the copper ions, undergoing a process called reduction. The result? Neutral copper atoms that attach themselves to the copper electrode. So, we have the zinc electrode losing electrons, that's oxidation. The copper electrode gaining electrons, that's reduction. Together, these two processes form what's known as a redox reaction, short for reduction-oxidation reaction. This redox reaction is the driving force behind a voltaic cell. But there's one more piece to this puzzle. It's a component called a salt bridge. This is a pathway that allows ions to move between the two containers. The salt bridge helps maintain a neutral charge in the solutions, which in turn maintains the flow of electrons from the zinc electrode to the copper electrode. In essence, a voltaic cell is a beautifully orchestrated dance of electrons and ions. It's a process driven by the natural desire of atoms to achieve stability, and in doing so, they power our world. To summarize, a voltaic cell works through a redox reaction where the zinc electrode undergoes oxidation, losing electrons, and the copper electrode undergoes reduction, gaining those electrons. The movement of these electrons forms an electric current. Meanwhile, the salt bridge maintains a neutral charge in the solutions, allowing the electron flow to continue. So the next time you use a battery-powered device, remember the intricate journey of electrons and ions that makes it all possible. It's a journey that starts and ends with the humble yet powerful voltaic cell.